higher than maths online. Today we'll try to deal with the topic of polar coordinates. Let us first try to study what polar coordinates are. So I'll just try to define with the help of this figure. Suppose if I consider this as the x-axis, consider a row OL and another ray OP. Let theta be the angle between these two lines. And this length OP can be represented as r, which is nothing but the radius vector. So we have this OP is nothing but r, and this r is called as the radius vector. And theta is the angle between these two lines OP and OL. Then this point P can be represented in the form of these two coordinates r and theta. Then this r and theta will be called as the polar coordinates. So the point P is represented in the form of the coordinates r and theta. So therefore these coordinates are called as the polar coordinates. Now let us try to bring about the relationship between the Cartesian coordinates x and y and the polar coordinates r and theta. So to bring about the relationship between the Cartesian coordinate and the polar coordinates, let me consider the figure. So I consider this figure where OX represents the x-axis, OY represents the y-axis. So let me consider the line OP, which represents the radius vector. So let me drop a perpendicular from the point P to the point Q. Let theta be the angle. This point P in the form of the Cartesian coordinate can be represented as x comma y, and the same point in the case of the polar coordinate can be represented in the form of P of r comma theta. So now let us try to bring about the relationship between this Cartesian coordinate and the polar coordinates. So for that, from the right angled triangle, so let me consider from the right angled triangle OPQ, let me consider cos theta value. Cos theta will be equals to, basic formula for cos theta will be equals to, suppose we are considering for this theta, this will be the opposite side, and with respect to this theta, this will be the adjacent side, and OP represents the hypotenuse. So the basic formula for cos theta is nothing but adjacent by hypotenuse. So let me take for the adjacent OQ, it is on the x-axis, it represents the coordinate x. So this distance is x, and over here this distance will represent your y value. That is what this point represents, P of x comma y. The x coordinate is OQ, and the y coordinate that is there represents PQ. So if I represent the adjacent side from the figure, what is adjacent? Adjacent is OQ divided by hypotenuse. So what is the hypotenuse value? Hypotenuse value is OP, which will be equals to, so what does OQ represents? OQ represents x divided by OP represents the radius vector r. So therefore we have got the value of cos theta to be equals to x by r, or I can rewrite this value to be equals to, so if we cross multiply this r on the other side, it becomes r cos theta is equals to x, or I can write this value as x to be equals to r cos theta. So you got x in terms of r and theta. So that's the first value I got. X is equals to r cos theta. Now again from the figure, let us try to find out sine theta value. Sine theta, the basic formula for sine theta is nothing but opposite by hypotenuse. So if you try to see from the figure, opposite side is nothing but PQ divided by hypotenuse represents OP. So PQ value from the figure is nothing but the distance y divided by OP from the figure represents your R value. So therefore, we have got sine theta to be equals to y by R. Cross multiply this R on the other side, we get R sine theta to be equals to y, or the value of y is nothing but R sine theta. So hence we have represented y also in terms of the polar coordinate. So y is equals to r sine theta. So Cartesian coordinate is represented in the form of the polar coordinate. So using these two results, I can find out the value of r as well as the value of theta. So for that, let me take this as equation number 1. Let me take this as equation number 2. So to find out the value of r, I'll just try to square and add these two values. So to find r, squaring and adding, squaring and adding equations 1 and 2. Equations 1 and 2. So left hand side, let us square and add it. So left hand side value of equation 1, if you square, you'll be getting x square plus, add that with the square of the equation number 2, left hand side, x square plus y square. Similarly, we'll try to square and add the right hand side value. Right hand side value of equation 1 is r cos theta. If you square, you'll be getting r square cos square of theta, plus if I square equation number 2 right hand side, I'll be getting r square sine square theta. If you try to observe the right hand side value, so what is common over here? Common is r square. So if I take r square as common, so I'll be left out with cos square theta plus sine square theta. But we know the value of cos square theta plus sine square theta will be equals to 1. So it is 1 times of r square will be r square. Therefore, we have got the value of r square to be equals to x square plus y square, or r will be equals to the square root of x square plus y square. The square goes on the other side and becomes the root. Therefore, the value of r will be square root of x square plus y square. So I've expressed r in terms of the Cartesian coordinate x and y. We obtained r in terms of x and y. Now similarly, let us try to obtain the value of theta. So to find theta, once again, we'll go back to this equation 1 as well as equation number 2. So to get the value of theta, we'll just try to divide equation 2 by equation number 1. So you can try to see over here, equation 2, if it is divided by equation number 1, in that case I'll be getting y by x on the left hand side. On the right hand side it will be r sine theta divided by r cos theta. we'll try to write divide equation 2 by equation number 1. So we'll be getting y by x on the left hand side. On the right hand side, the value of y is r sine theta divided by the value of x is r cos theta. So try to observe over here, you can cancel out the value of r. So this r and r will cancel out. So we are left out with y by x to be equals to sine theta by cos theta will be tan theta. So therefore we obtain the value of tan theta. So we obtain the value of tan theta to be equals to y by x, or theta will be equals to. So if we take tan on the other side, it becomes tan inverse of y by x. So we obtained theta in terms of x and y. So that's the value of theta. So we have seen that we have first expressed x and y in terms of r and theta. Then we have expressed r and theta in terms of x and y. So that's the relationship between the Cartesian coordinate and polar coordinate. So in the next session, we'll try to find out the angle between the radius vector and tangent. So that's all I have for today. Thank you.